Here's one more example we'll look at about using an exponential growth or decay function to estimate a population size. So if you watched our last video, you saw that we used this formula up here, y equals a times b to the x power. A was our initial population, y was our final population, at least when the problem is ending for us, and then x, or I often will just use t for the exponent, represents time. B is the growth rate or the decay rate, as we'll see in this example, and that's what we're not going to know this time, and that's what I want to find first. So once again, let's begin by writing an exponential function using the data they give us. So I can see that in this example, we are starting an initial population of Tasmanian devils of about 3.2 million in the year 2005. 5 years later, so I'm going to note that x is 5 in this case. They don't tell me that outright, but I, obviously doing some simple math, I know that 5 years have passed. They tell me my population later on, then this y value is the 420,000. So I can see that my population is declining. So I should get a growth rate, not a growth rate that's negative, but a growth rate that's less than 1, meaning I have a decay function. So let's get these values plugged in and see what we can do with this. So my y value, my final population, is this 420,000. My initial population was this 3.2 million, so I'm going to use commas to make sure I don't mess that number up. And then times b, which I don't know the growth rate, raised to the 5th power though because 5 years have passed. So dealing with some kind of ugly numbers this time, but using a calculator we shouldn't have too much trouble. I'll start with dividing both sides by the 3.2 million. I'm just going to do, never mind, let's write the whole thing out. Divide both sides by the 3.2 million. Pause, you can type that in your calculator, I guess. When I do that, I come out with about 0.13125, and that's equal to b to the 5th power. Well, at this point, I got to get rid of that 5th power, so I'll do a 5th root to do that. Remember, look on your calculators if you have a graphing calculator. Look under the math menu, and you should see this button, the y x root of y, whatever you want to call it. And using that button, you should be able to get this typed in your calculator to do the 5th roots of both sides. And when I do that, I find out that b comes out to be approximately 0.666 is what I wrote down. Spooky. Again, as we talked about in the last video, or check the problem or talk to your teacher about how many decimal places you should round these values to, because even a slight difference, even if I round that to a 0.7, for example, can have a pretty dramatic influence or effect on your final answer. So just watch out for that. So writing the equation, which is what they wanted, I'm going to go back to y equals my initial value, which was the 3.2 million, or 3,200,000, sorry, times the b value, which we just found, which was that 0.666 number. And then I'll raise that to the x, so now I can use this formula to find out my population at any time. And what they're asking me in part B of this problem is they're saying, well, what's your population estimate for the year 2050? Well, since we started in 2005 in this example, my number of years must be 45 years. So let's plug that in for x in this equation we just wrote. So I'm not going to rewrite that whole thing because it takes forever to write down. But go ahead and plug that into your calculator using 45 as your exponent. And you'll see that, sadly, this value comes out to be approximately 0.036. And so if I round that to the nearest whole number, my population in 2050 that I can expect is basically 0, meaning my Tasmanian devils are now extinct. So kind of a sad story, I guess, with that example. Let's hope that's not the case. But in this example, based on this information, we can expect those Tasmanian devils to be gone in the year 2050. We expect none are left.